Hello everyone. In continuation with the previous video of properties of rational numbers, we'll start with the next property. Before that, let's have a quick recap on what we learned in the previous video. We learned about the closure property and the commutative property. And we also saw that closure property is applicable for addition of fractions, right? When we add two rational numbers, sorry, not fractions, rational numbers, we get a rational number as the answer. When we subtract two rational number, we get the answer as a rational number. When we multiply two rational number, we get a rational number as an answer. Same way, when we are dividing two rational numbers, we are getting a rational number. So what did we talk about it? We said that closure property for addition, subtraction, multiplication, division is applicable. Means when you take any two rational numbers, you add them, you multiply them, you divide them, or you subtract them. The end result or the answer that you get is also a rational number. That was the first thing which we saw. The next was the commutative property. Now for commutative property, you need two rational numbers. And the order in which you are adding them or you are multiplying them does not change the answer. That is what the commutative property tells us. Whereas subtraction and division is not possible for commutative property. So if you are taking two rational numbers, say A by B and C by D, if you are adding them in any order, means any rational number can be put first, and after the any order, if you add them, the end result is going to be same. So it's true for addition, same way it's true for multiplication. But subtraction and division is not possible. It's not true. It's not possible means it's not true. If you change the order, you're going to get a different answer in subtraction and in division. Okay, so now in commutative property, we selected two rational numbers, right? So when you select three rational numbers, then the property is called as associative property. So you're taking three rational numbers, A by B, C by D, E by F. And there are three unique rational numbers. So when we are adding them, the way in which we group them, in any order we can group them, the end of the day, the result will be same. The answer will be same. So the normal way of grouping them, the usual way of grouping them is A by B plus C by D. You add the first two, the answer that you get, you add it to the third. Or you add the second and the third together, the answer that you get, you will add it to the first. So I'm going to do that in the given two fractions. Okay, I'm going to put them next to each other so that you can very clearly understand the method. What we are going to do is we are going to add the first and the second fractions together. And whatever, because I'm going to do it as a first part, so I'm going to put it in a bracket so that the PEDMAS rule can be applied. Okay, so first solve the bracket, whatever is inside, and then you add that to negative 3 by 5, right? So the LCM in the bracket will be 6. So it will be positive 3, negative 2. Okay, why? Because I'm going to multiply this by 3, okay, and this by 2. So if you want to show it, 1 times 3, 2 times 3, plus minus of 1 times 2, 3 times 2, correct? Plus of minus 3 by 5. So what will happen inside? 3 by 6 plus of minus 2 by 6 plus minus 3 by 5, right? So now what will happen? It will be a 3 minus 2 over 6 plus, still I am going to keep the bracket, is minus, let's write this plus into minus as minus 3. This plus into minus as minus 3. So this will give me what? 1 over 6 minus 3 over 5. So what's the LCM right now? 30, right? So I'll multiply this by 5 and this by, this by 5. 1 by 6 will multiply by 5 and this by 6. So I'll get 5 minus 18 by 30, which is going to give me a minus 13 by 30. Okay. Now let's look into the next part of it. What is the grouping that I'm going to do here? I'm going to keep the first number as such. I'm not going to touch it. I'm going to talk about the addition of the second and the third rational number. Okay, let's look into it. So here the LCM will be 15. So keep the half plus 1 into 5, negative 1 into 5, 3 into 5 plus negative 3 into 3, 5 into 3, right? So that will turn out to be a half plus minus 5 by 15 plus negative 9 by 15. Right? That will give me a half plus minus 5 minus 9 by 15. Right? So that will further give us half minus of 14 by 15. So what's the LCM going to be? 30. So I'll multiply 15 here and 2 here. Right? So 15 minus 28 by 15, which will give me, sorry, by 30, I'm sorry, 30, 15, 28 minus 15 is going to give me a 13, and 28 is having a minus sign, so minus this. So when we change the grouped order or the grouping, if you are changing the order of the grouping, still addition of three numbers is going to give you the same answer. So either you add the first two numbers and the result that you get, you add it with the third, or you do the second and the third rational number addition and add it with the first. So associative property is same as commutative property, that when you change the order of the fractional numbers, the answer is going to be same. But in commutative property, we deal with two rational numbers, and in associative property, we deal with three rational numbers. Okay, the same applies for associative property of multiplication. Okay, same, we are going to take three rational numbers and we are grouping it. Okay, then the rational numbers are multiplied by grouping in any order, then the answer will be same. Again, what we are going to do, we are going to multiply the first and the second. Whatever answer we are going to get, we are multiplying with the third. Or we can do is third and second multiplying together, and the answer that we get, we are going to multiply with the first. Let's do it again. I'll make it both the things I'll put on the both parts. So I'm going to do is multiply the first and the second. Put it in a bracket. Multiply by the third. So when I multiply here, the 3 and the 3 gets cancelled off. I'll get negative 4 over 7 multiplied by negative 11 over, sorry, 8 over 11. So now the numerator and the denominators are different. There is nothing to cancel off. So negative 4 and negative 8 will multiply. 7 and 11 will multiply. Minus into minus is plus, 32 over 77. Now, I'm going to keep the first fraction as such. Don't touch, I'm not going to touch it. So, I'm going to take the third and the second together. So, if you see in this one, the 3, 8, 7, 11, nothing is common between the numerators and the denominators. So, what we'll do, we'll simply multiply it. So, 3 times negative 8, 7 times 11. Correct? So, I'll get negative 4 over 3 multiplied by negative 24 over 77. Now, 3 ones are 3 and 3 eights are 24. Correct? Now, negative 4 and negative 8. So, that will give me a positive 32 divided by 77. Are we getting the same answer? Yes. So, associative property, again, I'm repeating, it deals with multiplication or addition of three rational numbers. You group the rational numbers in any order, you'll get the same answer. Okay. Now, the next property, additive identity. Identity means when the number's own property, the number is not changing in any form, then in any way it is not going to change. So any rational number when added to the given rational number, I'm going to get the same answer. So here the rational number is 0. When you add any rational number to 0, the answer is the rational number itself, because 0 is not going to change anything. So 0 is called as the additive identity. Okay, so a by b plus 0 or 0 plus a by b is going to give me the same rational number a by b. Same way 7 by 9 plus 0 is going to give me a 7 by 9, or 0 plus 7 by 9 is going to give me a 7 by 9. Right? Even if it's a negative rational, I'm going to get the same rational number. Right? So here 0 is called as what? Additive identity for any rational number. Additive, why? Because when you add 0 to the given rational number, the answer is the rational number, because 0 is not doing any change to the rational number. Similarly, we have multiplicative identity. So if you multiply any rational number with 1, it's not going to change the rational number, and the answer will be the rational number itself. So a by b times 1, 1 times a by b is going to be a by b. Clear? So negative 7 by 11 multiplied by 1 is going to give me the same answer, negative 7 by 11. Or I can say 1 multiplied by minus 7 by 11 is going to give me minus 7 by 11. It's not changing the answer. Similarly, 5 over negative 13, when it is multiplied by 1, it's going to give me negative 30. Sorry, 5 over negative 13. So here 1 is called as the multiplicative identity. The number that when multiplied to the rational number doesn't change anything. It keeps the same rational number as such. So additive identity is 0 and multiplicative identity is 1. Hope this is clear. Now, the next is called as additive inverse. So additive means add. So inverse means the opposite of add is subtract. So what we do, in terms of integers, we can say plus and minus, they are inverse to each other. So if it's plus 5, the inverse is minus 5. If it is plus 11, the inverse is minus 11. If it is minus 50, the inverse is plus 50. The same rule applies here. If we are taking a by b as my fraction, as my rational number, the additive inverse means just change the sign. It was plus, so put a minus. And when you add these two numbers, the answer should always be a 0. So negative a by b is called as the additive inverse of a by b. Or you can say the other way around. A by b is the additive inverse of negative a by b. So only the sign changes. So half, which number is the additive inverse? Just change the negative, put a minus sign. So when you add half with minus half, it gets a 0. Or minus half plus half, you'll get a 0. Same way, I have a minus 3 by 7. Just change the sign. What we'll get? Plus 3 by 7. So when you are doing a minus 3 by 7 plus 3 by 7, it's a 0. Or you do 3 by 7 minus 3 by 7, it's a 0. So to find the additive inverse, you keep the rational number as such and you just change the sign. That's all. Plus becomes minus and minus becomes plus. Whereas in multiplicative inverse, you flip the rational number. When I say flip means you just change the numerator to as denominator and the denominator to the numerator. That means if I am given a rational number a by b, flip means shift the b to the numerator and bring the a to the denominator, and that becomes the multiplicative inverse. And when you multiply these two rational numbers, you will get 1 as the answer. So b by a is the multiplicative inverse of a by b, or a by b is the multiplicative inverse of b by a. Just flip it. No change in the sign. The sign will remain the same. Okay, so 23 by 14, if it's multiplicative inverse, you shift the denominator to the numerator and numerator to the denominator. Just flip it upside down. So you get 1. I have not changed the sign. Same way, minus 51 by 37. Keep the sign in the numerator. Don't change it. Just flip the numbers from numerator to denominator and the answer will be 1. Hope this is clear. Let's take quick few questions. Okay. Now, write a rational number that does not have a reciprocal. Reciprocal means multiplicative inverse. Okay. Sorry for that. So reciprocal means multiplicative inverse. One rational number which doesn't have a multiplicative inverse is 0. Why? I can write 0 as 0 by 1. Right? But its multiplicative inverse means we have to flip the denominator to numerator and numerator to denominator. It will become a 1 over 0. I can never have a 0 in the denominator because the rule for rational number is p by q, where q should not be 0. Here I am getting my denominator as 0. So it's not possible. Again, why? 0 by 1 is a rational number. But when you flip it to, that is the only way to find the multiplicative inverse. Flipping means you shift the numerator to denominator. When you do that, you get 0 in the denominator. So such a rational number doesn't exist. So that rational number which has no reciprocal is 0. Okay. Next, rational numbers that are equal to the reciprocal, 1 and minus 1. 1 negative 1 over 1. If you just flip it, you're going to get negative 1 over 1. Similarly, if you have a 1 over 1, you flip it, you will get 1 over 1. So, they're equal to the reciprocal is 1 and minus 1 over 1. Clear? Next, the rational numbers that is equal to its own negative. Right? Negative means additive inverse, and that is a 0. Plus 0 minus 0 never exists.